Hello everyone, here we are to see some additional questions from grade 12 national exam of 2020. It is the second video. We have seen previously some question. We will continue solving. This will be the second video. So here it is. What is the sum of the infinite series? It says the summation 5 in bracket to the power of k plus 5 the power of k the whole over 10 the power of k. K starts from 0 to infinity, it says. I tried to do this kind of question in my previous video, but let us see how to do. Since the 5 is constant, we can take it outside. And then to the power of k over 10 the power of k plus 5 the power of k over 10 the power of k. We can give the denominator for each. So k is equal to 0 to infinity. This is the same as still the 5 will be outside. These two fraction, they do have the same exponent to the power of k 10 the power of k. So we can write 2 over 10 the whole the power of k. But 2 over 10 we can simplify it. It will be 1 over 5 the power of k plus, again, the other one, it will be 1 over 2 the whole the power of k. Because again, the same exponent, we can write 5 over 10, which is 1 over 2. Then this will be the 5, keep it outside. And this is geometric series. K starts from 0 to infinity. When you substitute 0 here, the first term will be 1. So G1 is just 1 over the common ratio is just 1 over 5. So 1 minus 1 over 5 we can make, plus the second one, again the same manner, 1 over 1 minus 1 over 2. The common ratio is 1 over 5 and 1 over 2 for both. But the first term is 1 over 5. I mean, when you substitute 0 here, it's going to be 1. Therefore, it will be 5 in bracket. Let us complete this one. When you subtract 1 minus 1 over 5, it will be 4 over 5. So we will flip it, 5 over 4. Plus, because the numerator here, 1, no effect. The same manner here. When you subtract, it will be 1 over 2. When you flip it, it will be 2 over 1, which is 2. Which will be 5 in bracket. When you add this one, it will be 8 plus 5, which will be 13 over 4. Then when you multiply, it's going to be 65 over 4. So the answer will be C. So you need to see the step-by-step process. What did I do? First, I give the denominator for each, as you see here. And then they have the same exponent. I wrote together 2 over 10 means it's 1 over 5, and 5 over 10 means 1 over 2. And then since it is geometric sequence and common ratio 1 over like less than 1, the common ratio, if it is between 0 negative 1 to 1, we can apply G1 over 1 minus R. This is infinite series formula. So we apply that one. But how do I get G1 for each? I substitute 0 here in place of K. When you substitute 0 here, 1 over 5 the power of 0 is just 1. That is G1. But the common ratio is the one which is found in the bracket. 1 minus 1 over 5, the second one also the same manner. We did that and we complete the bracket. But when I do here, I subtract the denominator, then we flip it. When you take the reciprocal, it's going to be 5 over 4. Here also 1 minus 1 over 2 will be 1 over 2. When we flip it, it will be 2 over 1 or 2. So when you add, how to add fraction. So the answer will be finally 65 over 4, which is found in C. Okay, the second question here, it is sequence. It says the second and the fifth term of a geometric progression are negative 1 over 2 and 1 over 16. The second and the fifth. That means G2. G2 means, by the way, G1 times R, which is given to you negative 1 over 2. And the other one, it is G5. G5 means it is G1 times R the power of 4. You know the formula for Gn. The formula for Gn is equal to G1 R the power of n minus 1. The exponent will decrease by 1. So this is given to you again 1 over 16. Therefore, in case of geometric sequence, we will not add or subtract, we will divide. So G5 over G2 means when you divide it, it will be G1 R the power of 4 over G1 R, which is equal to 1 over 16 over negative 1 over 2. That means negative 2 over 1. You will flip it. Okay, we are dividing G2 by G5. Then G1 cancel here, and what left here, this will be 3, R cube left. So R cube is equal to, when you simplify by 2, 1, this by 2, 8. So it will be negative 1 over 8. So when you put both sides in cube root, the R will be negative 1 over 2. Okay, in the first process, we have got the R. Then if we have R here, we can substitute the R here in the first equation here. when you substitute r, the g1 will be the g1 times negative 1 over 2 is equal to negative 1 over 2, means you can find the g1, which is just 1. Okay, we have g1 and the common ratio. What's asked? We are asked to find the sum of the a term, but sum of n, formula for geometric progression, it is g1 times r to the power of n minus 1 the whole over r minus 1. We can apply this formula. So the sum of 8 means the g1 is just 1, leave it. So the r is negative 1 over 2 the power of 8 minus 1 the whole over negative 1 over 2 minus 1. So when you do this, this is going to be 1 over 256. Okay, let us use the space properly. So according to the formula, when you substitute everything, we can ignore the g1 because we said it's 1 g1, so we can ignore it. Simply in place of r, substitute negative 1 over 2 the whole the power of 8 minus 1. Negative 1 over 2 the whole the power of 8 is the same as 1 over 256. You can check it, and minus 1 the whole over negative 1 over 2 minus 1. When you subtract these two, because both of them are negative, we can add, then put the negative finally, negative 3 over 2. Then the difference here, it's going to be negative 255 over 256. Then flip the denominator. When you flip it, it's going to be negative 2 over 3. Then cancel the negative here, and by 2 you can simplify 128. This one by 2, by 3 it's going to be 81. So the answer will be, 85 over 128. Yeah, it's somehow challenging, but we need to practice in this kind of question before we go to the exam. Very good. This is the second one. Let us continue to the next one. Okay, the third question is integration. As you see here, it says what is the value of the integral x e the power of e minus 1 plus e the power of x minus 1 the whole over x the power of e plus e the power of x. So we can apply substitution method. Let us take the denominator, the whole denominator, as u. U is equal to x the power of e plus e the power of x. Let us derivate it. Du will be, when you derivate this one, it's going to be ex e the minus 1 plus e the power of x. Derivative is just itself. But do I find this one in the numerator? No, but we can rearrange the numerator. The numerator function, we can write it x the power of e minus 1 plus e the power of x minus 1 means we can write it e the power of x over e. Okay, because the exponent negative 1 means times e the power of negative 1, we can put it down. Then by crisscross multiplication, what we can have, the product will be ex e minus 1 plus e the power of x, the whole over e. Therefore, we can take out 1 over e as a common. It will be 1 over e. Then what do I have? Ex e minus 1 plus e the power of x. Now, this one will be the numerator. The whole, everything here is the numerator, but this will be substituted by du. This is going to be dx. Therefore, as you see here, the numerator can be simplified and written 1 over e, then in bracket e times x the power of e minus 1 plus e the power of x. Therefore, we have here already du is equal to e times x the power of e minus 1. We derive this one. The derivative of this one, it gave us this. So we need to find the dx. So we'll divide both sides by the result, e x the power of e minus 1 plus e the power of x. When we divide both sides, the dx is equal to du over e times x the power of e minus 1 plus e the power. Okay, we need to substitute this one in place of du. In place of du means this is just, in place of dx. This is the whole dx. The numerator as it is, but after simplification we took it, and then the denominator already substituted by u. Then we can simplify. This one and this one are the same term. We can cancel each other. So 1 over e is a constant. We can take it out. 1 over e, keep it outside. In the integral, what left? Du over u left. This is the same as 1 over e ln u. But what's u? The u is already substituted this one. So we can write it 1 over e, then ln of the absolute value of x the power of e plus e the power of x, then plus c. So the answer is found in A. Yeah, the answer is found in A. This is going to be the third question. Yeah, somehow challenging, especially derivative and integral question we need to practice more because you are expected to do more. Very good. Let us continue to the next question. Question number 4. Question number 4, it says f of x is equal to 1 over x. Then we are asked to find the nth derivative. The nth derivative means in general for any n. So we have to see the pattern first. The function f of x is equal to already 1 over x means x to the power of -1. We can write it for derivative matter. It will be comfortable. So when you derivate the first one, first derivative will be the exponent will come as a coefficient. So negative of x to the power of -2 will subtract -1 minus 1. Again, the second derivative of x will be, again, -2 will come here, 2x to the power of -3. The third derivative, it will be -3 will come, -6x to the power of -4. And the fourth derivative will be, again, 24x to the power of -5. Now see the pattern. In the first derivative, the exponent is -2. In the second, -3. That means it's like increasing, but negative wise. If you bring it down, this will be -1 over x to the power of 2. But it will be in the denominator, but the exponent is increasing. It was 2, then 3, then 4, like increasing by 1, like more than 1. In the first derivative, it's 2. In the second derivative, it will be 3. So the exponent is simply n plus 1. For n, it will be n plus 1, the exponent of the x in the denominator. Okay, the other one, observe the coefficient. The coefficient is negative, positive, negative, positive. So the first one, it's negative, then positive. For even, it's positive. For odd, it's negative. Means we are derivating n times. We start derivating first. So n the power, like -1 the power of n, we can say. So generally, f n's derivative will be -1 the power of n. In the first derivative, it's -1 the power of 1. In the second derivative, it's positive, means -1 the power of 2 will be positive, obviously. So it will decide. The negative sign will be, or the negative or the positive side, or the coefficient will be decided by -1 the power of n. But the coefficient number, it was 1, then 2, then 6. That means this 2 means it is the same as 2 factorial, and 6 is the same as 3 factorial, and 24 is the same as 4 factorial. Okay, so the coefficient number goes by factorial. So we can say n factorial, the whole over x to the power of n plus 1. This is the general n's derivative. First of all, we try to determine the coefficient sign. It's negative, positive, negative, positive. So we can say -1 the power of n. And next, the exponent of the x, we already agreed. First derivative, it becomes 2. Second derivative, it becomes 3. Even if it's negative, we brought it down, no problem. So n plus 1. And the coefficient number, the magnitude, when you see, it was 1, then 2, then 6. How it's increasing? Factorial, 2 factorial, 3 factorial, 4 factorial, it will continue. So for the 4 factorial, for the third, 3 factorial. So that -1 the power of n, then n factorial over x the power of n plus 1. The answer is going to be this one. You can get this one in the choice. Very good. This is question number 4. Let us go to next question. Okay, the fifth one, it is again limit of sequence. What does it say? What is the limit of the sequence 1, 2 over 2 square minus 1 square, 3 over 3 square minus 2 square, again 4 over 4 square. Look, first term, second, third, fourth, it will continue in that manner. So if you observe the numerator, for first 1, second 2, so simply in general, the nth term, we are focusing on the nth term. The nth term will be n over, we have to say, because for 1, 1, for the second 2, for the third, for an, it will be n over. Again, the denominator n square. For 2, 2 square, 3, 3 square is the first one. But the next one minus n minus 1 square. Okay, because for the second one, if you see, 2 over 2 square minus the previous of 2. That is n minus. So this is a general form of an. Let us simplify this one. This is going to be n over n square. This is n. Let us write it properly. It looks a. Yeah, n square. Therefore, when you square this one, it will be n square minus 2n plus 1 when you square. Then it's going to be n over, let us distribute the negative. It will be n square minus n square plus 2n minus 1. So n square cancel. Therefore, an become n over 2n minus 1. Therefore, we are asked the limit. That means the limit of this sequence n over 2n minus 1 as n goes to infinity. The limit in general. We can divide each of them by n. So what will happen? The limit of, when you divide by n, it will be 1 over. When you divide by n, it will be 2 minus 1 over n. As n goes to infinity. As n goes to infinity, this is going to be 0. What left? Just 1 over 2 left. So the limit of this sequence will be 1 over 2 as n goes to infinity. This is question number 5. Let us go question number 6. Okay, the next question, it is asking us at what values of x, it says at what values of x does the function f of x equal to 4x cubed over 3 minus x to the power of 4 attains its maximum value. To check a maximum and minimum value, we need to derive and then we are going to factorize, and then we will try to construct sign chart, or we have to observe sign change. Positive, negative is maximum, and negative to positive will be minimum. So let's derive first. The derivative of this function, the first one, the cube will come, so 4 over 3, then the exponent come 3, then x squared minus, the second one, it will be 4x cubed. This is the derivative. Cut the 3. This is the same as 4x squared minus 4x cubed. Therefore, what's common here? 4x squared is common, so 1 minus x left. 1 minus. This is always positive. We can ignore this part because we are talking about maximum and minimum, so we need to observe sign change. Since this is a square, always positive, we can ignore and let's take only 1 minus x. So 1 minus x, when you construct sign chart, this will be 0 at 1. Therefore, below 1, it will be positive because the coefficient of x is negative. So less than 1 is positive, greater than 1 negative. So there is sign change at 0.1. Positive to negative means this is a maximum. So the maximum, okay, the function attains its maximum at x is equal to 1. We are asked at what point the function attains its maximum. So the answer will be at 1. Very good. This is question number 6. Let us go to question number 7. Okay, question number 7, it's asking us to find the derivative of the given function. The function is h of x is equal to square root of 1 plus radical x. We need to apply here a chain rule. So when derivative, remember radical x derivative in general, it will be 1 over 2 root x. That is the rule. So when you derive this function, it will be 1 over 2 times the whole everything, 1 plus root x. Times, we need to apply chain rule. What is the inner function? It's not only 1. 1 plus root x. We need to derive it. 1 plus root x must be derived. So according to chain rule, 1 over 2 square root of 1 plus root x times the derivative of 1 is 0. The derivative of root x is 1 over 2 root x. So when you multiply, it will be 1 over 2 times 2 will be 4. And we can insert the 2 together because it's multiplication case, we can put them together. So x times 1 plus root x. Because this is in the radical, the other also in the radical. So finally, when you simplify it, it's going to be 1 over 4 radical x plus x root x. We can multiply. X will multiply each of them. So finally, the answer will be 1 over 4 radical of x plus root x. These are some questions for today. From grade 12 national exam 2020. I will continue with another video. So for the time being, let me stop here. Don't forget to subscribe and follow me for additional questions or for general mathematical problems. Thank you for watching.